Okay, we're going to continue with Earth's atmosphere, looking at page 10. All right, page 10, we have two headings. The top one is layers of the atmosphere, and then within that we're going to learn about lower layers of the atmosphere, and then you can probably expect to read about upper layers. So we have a graphic on this page that talks to us about what the different layers look like and what happens in each of those layers. We're about to read about that. And then there's the Science Online. There's the Science Online link here where you can find out more information. Okay, so you can click this link here or you can type in this information to learn more about the layers. All right, we're going to start reading. So the layers of the atmosphere. What would happen if you left a glass of chocolate milk on the kitchen counter for a while? Eventually, you would see a lower layer with more chocolate separating from upper layers with less chocolate. Like a glass of chocolate milk, Earth's atmosphere has layers. There are 5 layers in Earth's atmosphere, each with its own properties, as shown in Figure 4. The lower layers include the troposphere and stratosphere. The upper atmospheric layers are the mesosphere, thermosphere, and exosphere. The troposphere and stratosphere contain most of the air. Now that was a lot of information. The main idea is that there are how many layers, and we're going to learn an acronym for those 5 layers. So you had written down 4. This was from the other day. So now under where you finished off from the other day, you're going to write Roman numeral 5, layers of the atmosphere. Main idea 1 is that Earth has 5 layers. Main idea 2 is the acronym TSMTE. And we will work with that acronym so that you can learn and memorize the 5 layers of the atmosphere. Now we're going to talk about each layer, give some characteristics of each layer. The lower layers of the atmosphere, okay, you study, eat, sleep, and play in the troposphere, which is the lowest of Earth's atmospheric layers. It contains 99% of the water vapor and 75% of the atmospheric gases. Rain, snow, and clouds occur in the troposphere, which extends up to about 10 kilometers. The stratosphere, the layer directly above the troposphere, extends from about 10 kilometers above Earth's surface to about 50 kilometers. As Figure 4 shows, a portion of the stratosphere contains higher levels of a gas called ozone. Each molecule of ozone is made up of 3 oxygen atoms bonded together. Later in this section, you will learn how ozone protects Earth from sun's harmful rays. So if we look at this graphic, okay, you have the troposphere. The edge of it's right here, and we live in the troposphere. 10 kilometers is 10,000 meters. It's a long ways. So everything we do is in the troposphere. The stratosphere is right above it, and this bluish layer is the ozone layer. And we'll talk more about that. So, okay, those are the 2 of the layers of the atmosphere. The upper layers of the atmosphere, hang on. All right, I'm back. Sorry, that was a error on my part. All right, so under the TSMTE that you wrote, you're going to put Roman numeral 6, lower layers. The lowest layer is the troposphere. It's at 0 to 10 kilometers, and it's where we live, where weather exists, has 99% of the water vapor, and 75% of gases. Right above that is the stratosphere. It is 10 kilometers to 50 kilometers above the surface of the Earth, and it contains the ozone layer. Ozone is 3 oxygen molecules. Pause the movie, write that down, and join me back. Okay, you're going to turn to page 11. All right, on page 11 we have 2 graphics. We have a graphic here about radio waves, and this is about the ionosphere. We're going to read about that in a minute. And then we have figure 6, discussing how the space shuttle moves in the exosphere. So we'll look at those in a minute. Okay, upper layers of the atmosphere. Beyond the stratosphere are the mesosphere, thermosphere, and exosphere. The mesosphere extends from the top of the stratosphere to about 85 kilometers above Earth. If you've ever seen a shooting star, you might have witnessed a meteor in the mesosphere. The thermosphere is named for its high temperatures. This is the thickest atmospheric layer and is found between 85 kilometers and 500 kilometers above Earth's surface. Now, within the mesosphere and thermosphere is a layer of electrically charged particles called the ionosphere. If you live in New Jersey and listen to the radio at night, you might pick up a station from Boise, Idaho. The ionosphere allows radio waves to travel across the country to another city, as shown in figure 5. During the day, energy from the sun interacts with the particles in the ionosphere, causing them to absorb the AM radio frequencies. At night, without solar energy, AM radio transmissions reflect off the ionosphere, allowing radio transmissions to be received at a greater distance. Let's take a minute and look at that image. Okay, so during the daytime, here is our radio tower, and this is regular radio. It's AM radio. You listen to FM, some of you have satellite. Okay, so when you're in the car, turn the dial to AM radio and listen to how that sounds compared to FM. So when you're on AM radio, you are getting radio waves from a tower, and during the day, the sunlight interacts with those radio waves, okay, and it prevents them from traveling a great distance. But at nighttime, the sunlight, the radiation from the sun, does not affect the ionosphere, and those radio waves can travel a great distance. So next time you are driving at night, try listening to the AM radio and see if you can get radio stations. I've gotten stations from Denver, Colorado, here in Greensboro. I've gotten Nashville, Tennessee. So it's kind of fun to listen to someone else's radio to figure out where it might be coming from too. All right, let's go back to where we were. All right, now we're going to finish this up by talking about the space shuttle in figure 6, orbits Earth in the exosphere. In contrast to the troposphere, the layer you live in, the exosphere has so few molecules that the wings of the shuttle are useless. In the exosphere, the spacecraft relies on bursts from small rocket thrusters to move around. Beyond the exosphere is outer space. So, if you think about the wings on a plane or a space shuttle, it's the air molecules moving above and below the wings that help the craft fly. But there are no air molecules in the exosphere. There's very few. So it has to have these bursts of jet that push the space shuttle forward. All right, let's get our notes down. Okay, so we took a few detours. Let's remind ourselves we're in the upper layers of the atmosphere. We're going to document 3 layers, their heights, and a characteristic. So we left off with the stratosphere. Section 7 is the upper layers. The next section above the stratosphere is the mesosphere. It was 50 kilometers to 85 kilometers high. That's where we find meteors, and that's where we find the beginning of the ionosphere. The thermosphere is 85 to 500 kilometers. It has very high temperatures, and the ionosphere is also contained in the thermosphere. The exosphere is above 500 kilometers and has very few molecules listed there. So a question that you might have is, why is the ionosphere not its own layer? And if you would like to Google that and find out why it's not considered one of the 5 main layers, you may do that. All right, this episode has been dedicated to 7th period, to Max and Landon and Lucas and Smith and Corey. Have a fabulous night. I'll see you tomorrow.